myself Dhanalakshmi. Welcome to session 4 of chapter 3 matrices of plus 2 mathematics. In this session we are going to discuss about how to find the inverse of a matrix by elementary operations. Let's recall the 6 elementary operations and the definition of the invertible matrices that we discussed in the last session. The operations are the interchange of any 2 rows or columns. Second operation, the multiplication of the elements of any row or column by a non-zero number. Third operation, to a row or column we can add row or column multiplied by a non-zero number. So these are the 3 row operations and the 3 column operations that we are going to apply in doing the problems using the elementary operations. Also, the definition of the invertible matrices says that if A is a square matrix of order M, and if we can find another square matrix of the same order such that AB is equal to BA is equal to identity matrix, then we can say that B is the inverse of the matrix A. So in this case we say that the matrix is said to be invertible. Now before applying the row operations in finding the inverse of the matrix, there are some conditions imposed on it. Let us see with an example. So let's consider the matrices 1, 2, 3, 4 and the matrix 2, 1, 0, 2 whose product is given as 2, 5, 6, 11. So we all know how to multiply the 2 matrices. The first row, first column, the first row, second column. Similarly, the second row, first column and the second row, second column, we get the answer 2, 5, 6, 11. Now let us take the product matrix as X, the first matrix as A and the second matrix as B. Okay. Now let me apply the row transformation in the matrix A, the first matrix. R1 is multiplied by 5, which means R1 transforms into 5R1. So we can see that when the first row is multiplied by 5 in the matrix A, it becomes 5, 10, 3, 4 multiplied by 2, 1, 0, 2. It will give us the product on multiplication. We get 10, 25, 6, 11. Now let us compare these two. So we can see that when the first row of the matrix is multiplied by 5, we can see that in the product also the first row is multiplied by 5. 5 2s are 10, 5 5s are 25. 5 1s are 5, 5 2s are 10. So when the change occurs in the first matrix A, the same change takes place in the product also. Therefore, we can see that if R1 transforms to 5R1 in matrix A, then in the product X also R1 becomes 5R1. So with this example, we can say that when we have to apply the row operation on the matrix equation X is equal to AB, it should be applied on the product X and the first matrix A simultaneously. Therefore, we can impose some rules on row operations. When we start the row operation on a matrix equation, first we have to write A is equal to I into A. We know that any matrix multiplied by its identity gives us the same matrix. So we are writing A is equal to I into A, and throughout we are going to apply the row operations on both sides till we get I is equal to B into A. That is, this matrix A is reduced to identity matrix and I is brought to some other matrix, say B. Therefore, by the definition of the invertible matrices, if AB is equal to BA is equal to I, we can say that B is the inverse of A. Therefore, we can say B will be the inverse of A. And the second rule which we can say is that when you are bringing A into an identity matrix on the LHS, we should bring it in this way, that is 1, then down 0, then make this element 1 and this position is 0. So for row operation, complete the first column, then come to the second column. So we can remember the U shape. The identity matrix 1, 0, 0, 1 should be brought in the form of a U shape in order to get the inverse of the matrix. Similarly, if we have to apply the column operation on the matrix equation, again there are some conditions imposed on it. Let's see with an example. Let me take the same example, 1, 2, 3, 4 multiplied by 2, 1, 0, 2, which gives us the product 2, 5, 6, 11. Let me take the product as X, the first matrix as A, and the second matrix as B. Here, I am going to apply the column transformation on the matrix B. So, if the second column of the matrix B is multiplied by say 3, so C2 becomes 3C2 in the second matrix B. Let's see what change takes place there. So, on multiplying these two matrices, after multiplying the second column of the matrix B by 3, we get the product 2, 15, 6, 33. So, let's compare these two. When the second column of B is multiplied by 3, so 3 into 1, 3 2s are 6. Here also the second column is multiplied by 3, which means the same change takes place in the product also. Therefore, we can say that when we apply the column transformation on the matrix equation, it should be applied on the product matrix and the second matrix B simultaneously. So, in order to apply the sequence of elementary column operations on the matrix equation X is equal to AB, we will apply these column operations simultaneously on X and the second matrix B. So, from this we write A as A into I, because when we are applying column operation, it should be done on the second matrix. Therefore, we can write A is equal to A into identity matrix, and we are going to apply the sequence of column operations on both sides simultaneously on A and I till we get I is equal to AB. I is the identity matrix, that's equal to AB. Like we say that if you ask what is the inverse of 2 with respect to multiplication, what do we write? 2 into 1 by 2 is equal to 1. It is giving us the multiplicative identity 1, which means 1 by 2 is inverse of 2. Similarly, here if we get I is equal to A into B, we can say that B is the inverse of A as per the definition of the invertible matrix. Second rule, we can say that we have to reduce that A matrix to identity matrix. That is, we have to bring in 1, 0, 0, 1. So, since it is column operation, let's complete the first row. 1, 0, then come down to this element 1, 0. So, if required, we can just remember it in the form of inverted C shape. So, these two results I can summarize and we can put it in that way that when we apply row transformation on a matrix equation, it should be done simultaneously on both sides and also on the first matrix. Similarly, when we apply the column transformation, it should be done on the LHS and also the second matrix on the RHS. we'll do some problems using the elementary operations like row operation and column operation to find the inverse of the matrix. So let's take on the first problem. Find the inverse of the matrix A is equal to 2, 1, 1, 1 by row operation. So you are asked to find the inverse of the matrix A is equal to 2, 1, 1 by row operation. As we discussed now, if we have to apply row operations, how should we start it? A is equal to I into A. This is the first step which you have to do, which implies A is 2, 1, 1, 1, I is 1, 0, 0, 1, and no change takes place in the second matrix when we apply the row operation. So no need to write anything there. A will be written in each step as it is. Transformation only on A and the identity matrix. Okay. So we have to bring 1, 0, 1, 0. We have to bring it in this form. So first we have to make this position A11 as 1. So this 2 should become 1. So we can go for two operations, like we can interchange R1 and R2 in order to bring 1 in A11 position, or we can also directly subtract. That is, R1 becomes, you know that 2 minus 1 is 1. So I can write R1 becomes R1 minus R2. R1 becomes R1 minus R2. So you can see that we are making the transformation in first row. So let's write the second row as it is, because we are not making any change in the second row. So fill in the second row first. Now we'll replace the first row using the transformation R1 minus R2. The corresponding elements of R1, R2 are subtracted. So R1 minus R2, 2 minus 1, 1. 1 minus 1, 0, 1 minus 0, 1, 0 minus 1, minus 1. So we have got this position, this 1 we got it. Next we have to get 0 in this position, that is A21 should become 0. So what can we do here? So compare these two. So R2, if you make the transformation R2 is equal to R2 minus R1, what happens? 1 minus the corresponding 1 will give us 0. Therefore, the operation can be written as R2 becomes R2 minus R1. That means we are not making any transformation in the first row. So let's write the first row as it is. Now we are going to make the transformation only in the second row. R2 is going to be changed, transformed into the new values. So R2 minus R1. So 1, the corresponding element 1, 1 minus 1, 0. 1, the corresponding element is 0. Here 0 minus 1, 1 minus of minus 1, 2. So we have reduced A is equal to IA as I is equal to, say, B into A. Hence, by the theory, we can conclude that this matrix, say B, is going to be the inverse of the given matrix. As we have got 1, 0, 0, 1, we have brought this in the form of I is equal to BA, which means B is the inverse of the matrix, that is, A inverse is nothing but 1 minus 1 minus 1, 2. So this is how we are reducing A is equal to IA in the form of I is equal to BA, where B is the inverse of the matrix. Now we'll see to the one more problem using the row operation. A is equal to 1, 2, 2 minus 1. We are going to find the inverse of the matrix by row operation. By row operation. So, when you are going to apply the row operation, the first step should be A is equal to IA as said earlier. That is, A is 1, 2, 2 minus 1. I is 1, 0, 0, 1 into A. So, we have to bring the identity matrix in the form of 1, 0, 1, 0. Remember the U shape. So, we need 1 in this position. So, 1 is already there. So, we need not make any change in the first row because 1 is already there. So, we need not make, now we have to bring 0 in this position. That is, A21 should become 0. Here 2 is there. The corresponding element in the first row is 1. So, how will we get 0? 2 minus that 1 should be multiplied by 2. So, that we get 2 minus 2 is equal to 0. So, how do we put it in the operation language? The second row is going to be transformed as the second row minus 2 into the first row. R2 is going to be written as R2 minus 2 into R1 because here 2 is there, I should get minus 2. 1 is already there. So, 1 has to be multiplied by minus 2 in order to get 0 there. Therefore, 2 minus 1 into 2, that is 0. Minus 1, R2 is minus 1 here. Minus 1 minus 2 into corresponding R1 is 2. So, minus 1 minus 2 into 2, that is we get minus 1 minus 4, that is equal to minus 5. Now, coming to this part, it should be done on both sides. 0 minus 2 into corresponding R1 is 1. So, 0 minus 2 into 1 is minus 2. Similarly, 1 minus 2 into 0 is 1. So, we got 1, we got 0 now. So, next what are we supposed to do? We have to make this position as 1. We are going to make the transformation in R2. So, which means R1 can be written as it is, and R2 is going to be transformed as. So, there we have to get 1. So, we should not go for any addition or subtraction because this 0 should not change back to some other number. We have already got 1 and 0 there. So, it should not be changed again to some other number. So, we should not disturb that value 0. So, only way to get the value 1 so that 0 remains as it is the only possibility is divide by the same number. That is R2 divided by minus 5. What do you mean by that? The second row is going to be fully divided by minus 5 in order to get A22 as 1. So, 0 by minus 5 is 0. See, the 0 is not affected. That is why we are dividing by the same number. Minus 5 by minus 5, 1. That is what we want. 1, 0, 1. So, whatever we do on the LHS, it should be done on the RHS also. Therefore, minus 2 divided by minus 5 is 2 by 5. 1 divided by minus 5 is minus 1 by 5. Now, we have got 1, 0, 1. Now, this A1, 2, the first row, second column element should become 0, which means we are not making any transformation in the second row. The second row will remain as it is. So, we can write it in order to avoid confusion. We are going to change only the first row. Why do we change? We want 0 in this position. The next question is, how will you get 0? This 2, corresponding element is 1. So, this 2 minus 2 will give you 0, which means this 1 should be multiplied by minus 2, so that we get 2 minus 2 is equal to 0. So, let us put it in the transformation language. So, R1 should be written as R1 minus 2 into R2. R1 is 2 minus 2 into R1 is 1. So, what do you get? 2 minus 2, 0. See, in that case 1 is also not disturbed because 1 minus 2 into 0 is 1 itself. 2 minus 2 into 1 is 0. So, we have got the identity matrix. We will do the same operation on the right hand side also. So, R1 minus, that is 1 minus 2 into corresponding R2 is 2 by 5. So, what do you get? 1 minus 4 by 5, that is 1 by 5. So, you write 1 by 5. You should be very careful when you simplify. So, again I will repeat it. R1 minus 2 into R2. R1 is 1 minus 2 into corresponding R2 is 2 by 5. So, on simplification, what do we get? 1 minus 4 by 5, that is equal to 1 by 5. Similarly here, 0 minus 2 into minus 1 by 5. So, what do you have? 0 plus 2 by 5, so 2 by 5. So, we can see that we have brought the equation A is equal to I into A in the form of I is equal to B into A, so that we can conclude B is the inverse of the matrix, that is A inverse is nothing but 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. So, the inverse of the given matrix, we got it as the matrix 1 by 5, 2 by 5, 2 by 5 minus 1 by 5 by applying the row operations. Now, let us do the problems under column operation. So, using the column operation, find the inverse of the matrix A is equal to 2, 1, 1, 1. We are going to find the inverse of the matrix A is equal to 2, 1, 1, 1 by column operation. So, let us recollect the theory. If you want to apply the column operation, the first rule that we have to follow is A should be written as AI, because the column operation should be done on the LHS and the second matrix on the RHS. Okay. So, what does it imply? 2, 1, 1, 1 is A into, because A is not going to get affected, so let it remain as it is, 1, 0, 0, 1. Now, I should reduce this A is equal to AI in the form of I is equal to AB, so that I can conclude B is the inverse of A. So, let us remember the rule for column operation. First, this 1, 0, this is 1 and we should make 0. We have to go in this way. So, first element I need 1, A11 I should make it as 1. So, we can write I am going to change the first column. So, there is no, we are not going to make any change in the second column. We are not going to make change in the second column. So, we will write as it is. The transformation is only in the first column, that is C1 I can write it as C1 minus C2, because 2 minus 1 will give you 1. So, it is 1. 1 minus 1 will give you 0. Similarly, it should be done on this side. 1 minus 0, 1. 0 minus 1, minus 1. Be careful about the sign. So 2 minus 1 is 1, 1 minus 1 is 0. Similarly here 1 minus 0 is 1, 0 minus 1 is minus 1. Now, so we got this 1 we got. Now we have to get this 0. That is, we have to make A1, 2 position to be 0. So we are not going to make any change in the first column. So let's write first column as it is. Only the second column is going to be transformed. How do you transform? Compare with the corresponding column element. Here 1 is here is also 1. So how do I get 0? By direct subtraction. 1 minus 1 will give you 0. Therefore, C2 becomes C2 minus C1. Second column minus the first column element. So 1 minus 1, 0. 1 minus 0, 1. 0 minus 1, minus 1. 1 minus of minus 1 is 2. 1 minus of minus 1 is 2. So we have brought it in the form I is equal to AB. By the definition of the invertible matrix, we can say that B is A inverse. So that is nothing but 1 minus 1 minus 1, 2. Hence we have found out the inverse of the matrix A equal to 2, 1, 1, 1 as the matrix 1 minus 1 minus 1, 2. And let's do one more problem using the column operation. A is equal to 1, 2, 2 minus 1 by column operation. Okay. The minute you see the word column operation, or if you want to apply the column operation, the starting step should be A is equal to AI, because column operation should be done only on the second matrix. So let's replace A now. 1, 2, 2 minus 1. This A will not be affected at all. So let it remain as it is. No need to replace the values. 1, 0, 0, 1. So now the rule is that for column operation 1, you should come in this order. So first I should make this value is 1. Already I have 1 here. So I am not going to make any change in the first column because 1 is already here. Now so this is settled. Now I want to get this 0. I should make 2, 0. So compare it with this element 1. 2 minus 2 will be 0. That is, this 1 should be multiplied by 2. Therefore, I can write the transformation C2 as C2 minus 2C1. So C2 is 2 minus 2 into corresponding C1. So 2 minus 2 into 1 is 0. C2 is minus 1 minus 2 into corresponding C1 is 2. So what do we get? Minus 1 minus 2 into 2. That is minus 1 minus 4. So what do we get? Minus 5. Similarly here 0 minus 2 into corresponding C1. 0 minus 2 into 1. So minus 2. 1 minus 2 into 0. 1 minus 2 into 0 is 1. We got 1, 0. Now we have to make this as 1. The second column is going to be changed. So we are not going to make any change in the first column. In the second column, this value should become minus 5 should become 1 there. So what can we do? This 0 should not be affected. So only possibility is C2 becomes C2 divided by minus 5. So 0 by minus 5, minus 5 by minus 5, 1. Here what do we have? Minus 2 by minus 5 is 2 by 5. 1 by minus 5 will become minus 1 by 5. Okay. So we got this one also. now I have to make this 0. That is, this 2 should become 0. That is 2 compared with the corresponding column element, second column element, it is 1. So 1 should be multiplied by 2. So 2 minus 2 will give you 0. The second column I am not going to make any change. So let me write it in the beginning itself so that we can avoid the confusion. I am going to transform only the first column. How is it going to be written? It is C1 minus 2C2. So 1 minus 2 into 0 is 1. 2 minus 2 into 1, that is 2 minus 2 0. So we got the identity matrix. So here you can see that C1 minus 2 into 2 by 5, that is 1 minus 4 by 5, that is 1 by 5. So this becomes 1 by 5. How is this element going to change? Again, C1 element is 0 minus 2 into corresponding C2 is what? Minus 1 by 5. That is 0 plus 2 by 5. What do you get? 2 by 5. So we can see that we have brought A to I, which means A is equal to AI has become I is equal to AB, which implies B is the inverse of A, and that is 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. So with this, we come to the end of this session. Thank you.